Tired of confusing tech jargon? Welcome to the Why Explained. We cut through the noise to decode the systems and explain the foundational principle.
Let's talk about failure. Specifically, how a machine, a thing with absolutely no feelings, can learn from its mistakes better and way faster than we can. And no, it's not magic. It's all about a special kind of math. Let's get into it.
Just think back for a second. Maybe it was learning to ride a bike, or that first time you tried a new recipe and it went, well, totally wrong. You remember that feeling, right? That little internal, okay, don't do that again moment. That is the very engine of how we as humans learn anything.
It's this super simple cycle we're running all the time, mostly without even thinking about it. You try something, you fail, you notice what went wrong, and you adjust. This loop is how we get better at, well, pretty much everything.
Okay, so that's how we do it. But that brings up a really fascinating question. If our learning is so tied up in feelings and reflection, how on earth does a machine, a thing of pure logic, ever get better at anything?
Yeah, a machine doesn't get embarrassed when it gets an answer wrong. It doesn't feel the sting of failure. So where does its motivation to improve even come from? Well, it turns out it comes from pure, cold, hard numbers.
And this is the absolute key. We have to completely redefine what a mistake even is. For a machine, a mistake has zero emotion tied to it. It's just a number. It's the measurable mathematical gap between what it did and what its goal was. It's not a feeling, it's just data. And you know what? That level of detail is a total game changer. It's one thing to know you were wrong, but to know you missed your target by exactly 10 pixels to the left and 2 pixels up, that's not a failure, that's a map. It's a precise set of directions for the very next attempt. So this whole process, getting that super precise feedback and then adjusting, that's the fundamental engine of learning. It doesn't matter if you're a human or a computer. Let's break down the 4 simple steps that make this whole thing work.
It's this simple 4-step dance. First, you act, make a guess. Then, you observe, see what happens. Third, you compare. You measure how close you actually got. And finally, and most importantly, you adjust. You use that comparison to change what you do next time. Over and over and over again.
So, if we and the machines are running the same basic playbook, what gives them that incredible edge? Well, it all boils down to one thing, just ridiculous, mind-bending speed. Think about trying to learn how to juggle, right? You might give it a shot, 5, maybe 10 times a day if you're super dedicated? Our brains get tired, our bodies get tired. We have a hard limit on how many times we can run that learning loop. Now, a machine, it has no such limits. It can run that exact same 4-step loop millions of times. Not in a day, in a single minute. Each cycle, it makes a tiny adjustment, getting just a little bit less wrong. The progress is just astronomical. And at that scale, the whole idea of a mistake just completely changes. For us, failing over and over is discouraging. For a machine, a mistake is just a signal. It's pure, valuable information. In fact, a machine needs mistakes. Without them, there's no signal, no feedback, and absolutely no learning. It's kind of the opposite of how we think about it.
So we're both using the same core principle, learning from feedback. But the way we each get there, well, our paths couldn't be more different.
You see, our learning is all wrapped up in memories, in emotions. A machine's learning is built on raw data, just numbers. But here's the biggest difference, and it's a huge one. We are always trying to understand why something works. A machine just needs to know that it works. And that's what gives us our creativity and flexibility, right? But it's also what makes a machine so incredibly powerful at a single narrow task. And this really gets to the heart of a machine's greatest strength, but also its biggest vulnerability. It trusts the feedback it gets 100%. No questions asked. So, if that data is good, it learns with superhuman efficiency. But if the data is biased or flawed or just plain wrong, it will learn the wrong lesson perfectly. It's that classic garbage in, garbage out problem. Ultimately, when you boil it all down, it comes back to this one simple idea. Whether you're talking about a child learning to walk or the most complex AI on the planet, learning is simply the process of using feedback to adjust what you do next. And that's really the big takeaway, isn't it? We learn through understanding and finding meaning. Machines learn through pure calculation. Two profoundly different paths to the exact same goal, getting better. So we've seen the engine of learning, right? But how does that engine actually fit into the rest of the car?
How does it connect to all the data and the logic that make up a full machine learning system? Well, that's exactly what we're going to dive into next time. Thanks for joining me for this explainer.
Now you know the why behind this concept. If you want to master the systems that run our world, hit subscribe for more foundational explanations.